everyone, you're welcome to Explore Insights. In today's content, I want to talk about data flow diagram. If you're just joining for the first time, please do well to subscribe. So let's quickly dive in. Talking about data flow diagram. Data flow diagram is a graphic representation of how data moves from a system or process. How is data flow diagram utilized? So let's see through. 1. Data flow diagram are utilized to depict the input and output flow of data. Another one is to identify the activity that change data. Next is identify the attributes that are stored in the system. And lastly, to identify the attributes that are used by other activities or organizations. The next I would like to talk about is the data flow diagram notation. Now, different experts like Tom DeMarco, Chris Gain, Trish Sanson teamed up in different combinations to be the main definers of the symbols and notations we use today. So let's see what we have. Towards my right, we have Yondon and code. Here, the entity component is represented with a rectangle shape, and the process with a circular or oval shape. For the data store, it is represented as a rectangle with the right side open. And then for the data flow, it's depicted by an arrow. Moving over to Yondon DeMarco, quite similar to Yondon and code, the entity diagram also is represented with a rectangle shape. The same goes for the process. However, for the data store, it is being drawn as two parallel horizontal lines, and the data flow is the same as Yondon and code. Let me talk about the third notation. Here, the SSADM stands for Structured System Analysis and Design Method. This is quite different from the other three we can see on the slide. Now, the entity diagram has a circular shape. The process is represented with a square shape. The data store is similar to that of Yondon and code. And we have the same for the data flow, which is just an arrow. Next I want to talk about is Gain and Sanson. The entity component is similar to Yondon DeMarco and Yondon and code. Whereas for the process is quite different, which is seen to use rectangle with rounded corners. Moving over to the data store, it is a rectangle with the right side open. And for the data flow, it uses the arrow. Additionally, it can be seen that both in the data store and the processes, we have the reference tag. I would like to talk about this later. And what could be the similarities about this different notation? It could be seen that the data flow uses the same arrow. Now, let me talk about the types of data flow diagrams. We majorly have two types, which are the logical data flow diagram and the physical data flow diagram. For the logical data flow diagram, it's majorly focused on the system process. It can be called the business perspective. It is also used for smooth running of system in various organizations. For instance, it can be utilized to describe how data is moved from one entity to another. The physical data flow diagram depicts how data flow is actually implemented in the system. It is also seen as information system perspective. It is more specific and close to implementation. Now let's see through the main components. Data flow diagram has 4 components. 1, the external entity. So in this diagram, you can see 2 entities. Next is the process. So in this diagram, we have 2 processes. And next is the store, which can be seen here. Next, we have the data flow, which can be seen in 4 places. Moving further, I would like to give you more details about each of these components. The external entity. The external entity is referred to as actors, sources, or sink, which can be seen in this diagram. Another point is a system from outside the visualized system that delivers or receives data. Now, they are the sources and the destinations of information leaving or entering the system. Now, they might be an outside organization or person, a computer system, or even a business system. Remember that every external entity must be labeled as a noun. For example, we have customer, process. The process component is an activity that modifies or transforms data streams. All processes need inputs and outputs on a data flow diagram because they convert incoming data to outgoing data. Now, to label process on a diagram, this symbol is given a straightforward name depending on its functionality, such as order item, which can be seen here. Let me quickly say that there are 2 major considerations for labeling process. Process description must be an active verb noun format, and a reference number is placed above. Yeah, the process is labeled as order item. The order is the active verb, and the item is the noun. Also, the reference number of 1.0 indicates the level of the data flow diagram. On a data flow diagram, processes are normally arranged from top to bottom and left to right. Talking about data store components, it simply keeps data for later reference rather than generating any operations. Also, data store may include files that are kept for a long time or a batch of documents that are temporarily stored while they wait to be processed. Information or action that modify the stored data are included in input flow to a data store. And lastly, data retrieved from the store would go out as output. Next is the data flow component. The data flow component, which is represented as an arrow. Now, this arrow sign is used to depict the data flow between external entities, processes, and data stores, and to also denote the direction of flow. This information may be spoken, written, or electronic. According to the type of data, the related process of the data store, input and output data flows are labeled, and this name is written next to the arrow, which we have here. So the name we have here is product. Finally, take note that they are labeled as noun. Let's look at the different levels of a data flow diagrams. Here we have 4 levels of a data flow diagram. The context diagram, also known as the data flow diagram level 0, the data flow diagram level 1, the data flow diagram level 2, and the data flow diagram level 3. Let me explain each level. Now, the context diagram, which is known as the data flow level 0, it provides a general summary of the entire system or process that is being studied or modeled. This system is displayed as a single high-level process together with its relationship to external entities in what is intended to be an at-a-glance view. A large audience, such as business analysts, data analysts, stakeholders, and even developers should be able to understand this level with ease. Looking at level 1, the context diagram, that is level 0, is broken down more specifically in DFD level 1. The decomposition of the context diagram high-level process into its sub-processes draws attention to the principal functions that the system performs. The next level is level 2. The data flow diagram level 2 decomposes even more deeply into some of the level 1 parts. To provide the essential degree of details about how the system works, extra text may be needed. Also, the number of inputs and outputs in each process in level 1 must be maintained in level 2. Let me talk about the rules of data flow diagrams. 1. Data must not flow between two entities. 2. Data must not flow between two data stores. 3. Data must not flow from an external entity directly to a data store. 4. A process must have both input and output data flows. 5. The number of processes in a DFD should not exceed 12. 6. All the processes must be linked to at least one data store or another process in the system. And the last one is a data store must have both input and output data flows. Now let's look at a good example of a content diagram, level 0. So taking this as a case study, it says, consider Sweet Coffee, a new coffee shop at CDUT University campus. The shop's owners recently decided to develop a coffee ordering system. Now, these are the things that we need to look at, understand, and develop the coffee ordering system. So I'm going to go through this and be able to generate the context diagram, which is level 0. The first thing we have here is the system takes orders directly from customer. So which system? It's referring to the coffee ordering system. Now, which component is the system going to use? Definitely is the process component. The next thing we need to consider is the data flow. Now, we could see that the data flow information is this, which is takes orders. And the system takes order from who? From the customer. The customer here will be the entity. So let's go ahead and draw this. So this is what we'll have. Remember, I will be using the gain and sensing notation in my videos. So the ref number is 0.0. Here we have the coffee ordering system. The data flow, we have orders. And the entity, we have customer. So it means the customer sends order to the system. Next, it says, send the coffee order to the barista. Who sends the coffee order? System. So we are going to still use the coffee ordering system and create a new entity. And remember, this is the data flow information, coffee order. So we will have this diagram. Here we have the coffee order and the new entity we'll create for barista. Now we have monitors goods sold and inventory and generates reports for the shop manager. Who monitors the same system? Please, in every information system, take note of this comma. Now, the system will monitor goods sold and inventory and generate reports for the shop manager. Before now, we only have entity for customer and barista. So we have to create a new entity for the shop manager. And in order to shorten this, we will see it as management reports. So let's see what we have. So we have this management report, shop manager as the new entity. So it means the system will generate reports for the shop manager. So let's see what we have. And after this, we have a full stop. Let's see what starts new. It says, if the customer pays by credit or debit card to the system. So let's hold on here. What do we have? We have customer using the entity components and the system, the process components. Pays by credit debit card. So this tells us the data flow information. So we'll go ahead to create this. Take note that we already have customer here and also the system. So we will not be creating a new entity. Rather, we'll be using what we have and just make a new data flow. So this is what we'll have. So the customer pays credit card to the system. Now let's see the other thing we have, which is the system will also send a cash withdrawal request to the bank. Now if we go through this, we never had a new entity or any entity as bank. So to this, we are going to create a new entity and title it bank. Now let's take note of the data flow information. It says sends a cash withdrawal request. Let's come up with what we have. We're going to have this withdrawal request to the bank. So you can see we created a new entity and named it bank. And it says when approved. It is possible that the bank can reject, but at this point we said when approved. Who approved? The bank. To who? The system. So we are going to use the same information, which is the bank and the system. We won't be creating a new entity. Rather, we will have a new data flow. And for this information, it said when approved. So let's see what we have. Here, we'll call it withdraw approval. The bank to the system. Now let's see. Lastly, we have the system will generate receipts for the customer. So let's see the outcome. So we are going to have this. The system generates receipts for the customer. So I hope I'll be able to break down this case study for you to understand the detail about it using the data flow diagram. Do well to check my subsequent videos, as I will also treat the level 1 of this same case study. Additionally, I will also come up with different systems, and I will be looking at level 0, level 1, and level 2. Remember to go back to the slide to have more understanding on my explanation. Do well to subscribe to this channel. So I'm signing off now. Have a nice time. Bye.